So let's continue with our program. We have already connected our next keynote speaker. It's Dr. Sjaak Wolfert. I don't know if I correctly pronounce your name, Dr. Wolfert. He's a leading researcher in the Wageningen University regarding on digital innovation in agri-food. And the presentation that he will give to us, it's entitled "The Digital Innovation in the Agri-Food Sector, Pathways Towards Digital Transformation of Sustainable Food Systems." So, Dr. Wolfert, thank you for joining us, and the floor is yours.
Yes, thank you, Albert. And you pronounced my name quite well, so no problem. I already started to share my screen, so is the presentation visible?
Yeah, sure. We are seeing your presentation.
Okay. So yeah, welcome to my presentation about the digital innovation in the agri-food sector, showing pathways towards a digital transformation for sustainable food systems. So as Albert says, I'm a senior scientist at Wageningen University and Research. And the outline of my presentation consists of 3 parts. First, I will describe the trends and developments concerning the digital transformation of the agri-food sector. This will conclude with a definition of the innovation challenge for digital innovation. Then I will introduce an integrated innovation approach to address this challenge. And finally, I will use a real-life example from wine production to illustrate how this approach works in practice. And then I will end up with some conclusions. So let's first have a look at how the digital transformation of the agri-food sector is taking place. So what is happening in this picture has become a common phenomenon in modern supermarkets. Maybe you are also scanning your groceries and checking your shopping list in this way. And you can't wait to open this package of famous Dutch cheese at home and taste it. But do you know where the cheese has come from? How was it produced? And when I eat it, what is the impact on my ecological footprint? The barcode suggests that there is a lot of data to answer these questions. But what infrastructure is needed for this? And are food producers willing to share the data? And are you, as a consumer, willing to pay more for this information? If yes, who benefits most from that? The retailer or the farmer or someone else? So let's explore this dynamic world of digitalization that is behind this simple barcode, which, as you will learn, has 4 applications. First, decision-making in companies or for consumers. Secondly, food integrity. And third, public decision-making by public authorities. And finally, the 4th one, science and technology development. And the main message for you to remember is that the digital transformation is not only a technological development. It also requires insights into organizational changes that come along with it. So the food production chain from farm to fork, so to say, has become increasingly digital. And this is due to the so-called cyber-physical management cycle of smart sensing and monitoring, smart analysis and planning, and smart control. All kinds of objects such as crops, animals, or trucks are monitored by smart sensors, satellites, or drones with cameras. They are smart because their observations go beyond human senses such as sight, smell, and hearing. And moreover, they are capable of observation 24/7 without becoming tired. So that is also in relation to the questions we just had with the previous presentation. Maybe they are slower, but they won't become tired in the end. So smart sensing and monitoring results in a lot of data that is analyzed through smart algorithms and software applications. And the result could be an instruction to fertilize your crops or to treat your animals. And this planning is executed by smart machines, as was also showed in the previous keynote, that know the local context and what the optimal treatment for your crops or animals is. The loop is closed again by monitoring the effect of the control actions. And in this way, you can see if the growth of your animals, for example, or your crops is going into the right direction. This decision-making cycle can be applied to every object and company and the whole value chain. Also to consumers who are deciding what cheese they want to buy in the supermarket. This is the first application of digitalization in which data is used for decision making. The second application of these data is for food integrity, meaning that you can pass the data through the whole chain to address questions such as where does my food come from, or how was it produced, how many pesticides were applied, how long did the animals live before they were slaughtered. However, this requires a technical infrastructure of information systems between companies that exchange data. And here, standardization of data comes into play. If, for example, two companies use a different name for the same pesticide, it becomes a problem to exchange the right information. But beside technical issues, there is also the question if companies are willing to share data. And if they are forced to share, how do you know that the data haven't been tampered with? And even if companies are willing to share data, do they want to invest in these smart sensors, software, and machines from the previous slide I showed? And can these costs be passed on to the rest of the value chain? And if you're unable to make these investments, does it mean that you will be excluded from a certain market channel? The third application of the same data is for public policies. The data could be used to control food safety, support environmental policy, or health policies. Currently, most governments have their own separate monitoring systems or censuses that are usually lagging behind the actual situation. What if you could plug in to this real-time data to monitor nitrogen emissions or detect the food contamination right at the source? That would be fantastic, right? But what happens if data are used for other purposes? What if your company is marked fairly or unfairly as fraudulent and the authorities close it down? And more positively, are you also rewarded if your data indicate that you are producing in a more environmental friendly way? The fourth and final application area of data science is data science and technology. Examples of technologies are artificial intelligence, blockchain, Internet of Things, or big data analytics. And actually, these technologies are the main drivers behind this whole digitalization. But at the same time, their development depends on the data that are produced through the application of these technologies. So I always say you can do big data analytics without access to big data. Traditionally, scientific knowledge is produced by analyzing data from controlled library or field experiments. But the applicability outside that context is always limited. Your situation is always different and not as controlled as compared to those experiments. But nowadays, modern data science is able to analyze large amounts of data, of real-time data from different sources. The outcomes can potentially be applied in a much more specific context for your field, your crops, and your animals. The question remains, are you willing to share your data with scientists for this purpose? And further, scientists usually need data from other sources, for example, your competitors, to create benchmarks and trustful algorithms. And are you able to mobilize your sector or branch to organize this in a mutually beneficial way that everybody can trust? So in conclusion, the digital transformation of agri-food is taking place through the introduction of all kinds of smart devices and software. This results in a lot of data that has unprecedented potential for decision-making in companies or for consumers. Secondly, for food integrity, public decision-making by public authorities, and finally, science and technology development. Now, the innovation challenge for this digital transformation can be formulated as follows: how to create data-driven solutions that utilize the potential of digital data to support sustainable food production. The raised issues in this presentation indicate that you have to address technical and organizational issues at the same time, which are on data infrastructure and analytics, on creating technical systems and algorithms, business modeling on the added value of data-driven solutions, but also governance and ethics of data sharing, on making agreements and setting rules between organizations. So let's now have a look at how this challenge can be addressed by an integrated innovation approach. Digital innovation is often associated with smart machines, such as this autonomous robot in this picture, and that you also saw in the previous presentation. However, putting such a machine in the orchard is step one, which is relatively easy maybe. But to make this machine useful for your purposes, which is creating added value, is step two. In this presentation, I will introduce you to an approach for digital innovation that provides a framework for taking the next steps. So let's find out where it leads us. The approach to digital innovation starts by defining a use case project in which you are going to develop a certain digital solution. A use case means that you already start to use the solution in the project. It is tested in a real-life environment in which user involvement is a key success factor. Development of digital solutions consists of a cycle of 3 steps. First, design. Secondly, implementation and testing. And finally, evaluation. And dependent on the outcome of this last step, you're going to adapt your design again and go through these steps again. To guide this cycle, it is important to set clear objectives for the use case project. What do you want to achieve? For example, to increase yield, reduce pesticide use, or better transparency for consumers. And the spiral in this picture indicates how you go through the development cycle, but each time you try to end up at the next level. This next level is determined by so-called minimum viable products. A minimum viable product is a version of a product or service with just enough features that can be evaluated by the users. Each next minimum viable product adds more features until you reach the stage at which the digital solution is mature and can be introduced at a large scale. This means that a minimum viable product is more than just a technical prototype to see if it works. Features should also include aspects of practical use, costs, and benefits. User testing, asking, do users need my app or my digital solution? And usability testing, asking, can users use my app? Are the key principles to guide the development of digital solutions. Therefore, it is important that you have stakeholder involvement throughout the whole development cycle. Stakeholders can be, for example, technology providers, farmers, logistic providers, consultants, or researchers. Depending on the specific context and scope of an innovation, a use case project can last from several months up to several years. Also, the period of the development cycles can vary from weeks to months or years. A use case project usually takes place at a relatively small scale. A few organizations and persons form the core. This is inherent to the character of a use case in which you want to create a safe and trustful environment. The involved stakeholders want to learn by mistakes without being watched by too many people. However, there is also a risk that the use case is too isolated and has poor access to other experiences, so other use case projects and state-of-the-art knowledge. It's also important that digital technology is built on standards in order to be able to scale up afterwards. Besides, there can be external factors such as laws and regulations that determine the success of the innovation. So therefore, it is important that the use case is supported from 3 different disciplines. These are data science and information management, business modeling, governance and ethics, and ecosystem development. So let's have a closer look now at these 3 disciplines. The first discipline is data science and information management. Data science helps to analyze data according to the latest techniques and scientific insights. Information management helps to organize data exchange and integration between various devices and systems that are involved. It is important to think about the information architecture and data standards to be used. This is not only a technical thing, it interacts with business processes and users of the various organizations involved. The second discipline is business modeling, governance, and ethics. And although these can be approached as 3 separate disciplines, they're usually much intertwined. Business modeling helps to define the added value of a digital solution at stake. What are the costs and benefits, and how are they shared between the different stakeholders? Through the development cycle, it can appear that many data gets into the hands of a particular stakeholder. So how do you want to deal with that? And that's where governance and ethics come in. What are the underlying values that determine who you want to do business with, and what kind of agreements do you want to make about sharing data? The third discipline is ecosystem development. This already starts at the preparation phase of a use case project. With whom are you going to work on developing the digital solution? And during the development cycle, it can be necessary to involve other players. And if you want to scale up the innovation, you have to find new investors and the right communication and dissemination channels. And although these disciplines, data science and information management, business modeling, governance and ethics, ecosystem development are presented here in 3 separate blocks, in reality, there is also much interaction and overlap between them. For example, the choice of a particular business model will influence the way you build your information architecture. It could also be the information architecture could be very open or closed. And for example, ethical choices can lead to inclusion or exclusion of certain types of organizations, and thus influences the way the ecosystem develops. The involvement of these 3 different groups of disciplines can be organized in various ways. If you have a single use case project, you can include researchers, consultants, and communication managers that bring in the knowledge and expertise that is needed. Another possibility is that a use case is embedded in a larger project with multiple use cases. In that situation, dedicated expert teams are supporting the use cases from these different disciplines. Like that, you can also learn from other use cases. In summary, digital innovation should take place in use case projects that follow a cyclic, collaborative approach supported by multiple disciplines. This means that you are working together in a real-life context of a use case projects to develop a certain digital solution. Together with multiple stakeholders, you go through these cycles of design, implementation and testing, and finally evaluation. And in each cycle, you develop a minimum viable product that can be supported and evaluated from different technical and organizational disciplines, which are data science and information management, business modeling, governance and ethics, and ecosystem development. And in this way, a large-scale adoption of the digital solution is best guaranteed. So let's now have a look at how this innovation approach works in practice by taking a real example from wine production. Big Wine Optimization was a use case project in the EU-funded large-scale pilot, the Internet of Food and Farm 2020, IOF 2020, that you might have heard of. The general objective of the use case was to develop Internet of Things tools for sustainable wine production, wine quality management, and shipping monitoring. The ultimate challenge for this use case was to develop a sustainability footprint for a bottle of wine based on digital data. This should be used to differentiate at the retail level and target a specific group of consumers. To that end, 3 IoT products or services were to be developed. First, a wine sustainability tool to manage sustainability at the vineyard level, a wine quality control tool to control quality in the cellar storage, and a wine shipping monitoring tool to monitor the quality during the transport to the retailer. Together, these should provide the necessary information to make up a story about the sustainability for each bottle of wine. The use case project lasted 4 years, and it would be too much for now to go into all developments in detail. So let's zoom in on the development of the wine sustainability tool for vineyard management. First, challenges were defined, such as precision viticulture deals with huge amounts of data, and too much time is required to process them without appropriate tools, and real-time decisions are needed. And from these challenges, core features were defined, such as a professional dashboard for key parameters transmitted from IT sensors in the vineyard, and a single, easy-to-use interface to display, aggregate, and interpret data in real time. Based on these features, the use case was designed by putting sensors in the vineyard that produce the relevant data, And from this data, dashboard applications were developed that contain relevant management information concerning sustainability goals. Based on this information, management practices were adjusted in order to reach the sustainability goal. And the loop is closed again by measuring to what extent these goals were reached or not. According to the innovation approach used, this cycle was repeated several times. Each time a minimum viable product was defined and evaluated by the stakeholders. It means, for example, that the dashboard was not developed at once, but they started with a first sketch that gave an idea of the necessary sustainability information, and after an evaluation round, it could be decided to include additional sensors in the vineyard or to include other management practices. And as explained in the beginning, the use case was supported by several disciplines, indicated by the green blocks. Let's first zoom in what this means for data science and information management. So the sensors in the vineyard capture a large amount of data that need to be captured, stored, transferred, transformed, and finally to be analyzed. All these actions finally need to put the data together in the dashboard to show relevant management information. And this information should be the basis for actionable knowledge to implement the appropriate management practices. Let's now have a look at the ecosystem development. So the main initiators of this project were the wine grower and the producer, the Nid du Bourdieu domain from the Bordeaux in France, and ST Microelectronics, a semiconductor company and leader in IoT components. Du Bourdieu was already active in making wine production more sustainable, and ST Microelectronics had ideas to enhance sustainability with the use of all kinds of advanced sensors and technology. Process to Wine was or is a local startup company that was involved to build a marketable product and service around this idea. However, they didn't have all the required technical expertise, so they involved Isvea, Bordeaux INP, and SIA as a partner. And to scale up the solution, Vinidia was involved as innovation broker and for dissemination to other wineries. Let's finally have a closer look at the business modeling, governance, and ethics support. The big wine optimization use case was supported in developing a product fact sheet. An important part of that was to set a number of relevant KPIs, such as to reduce the production costs with 10%, reduce monitoring with 15%, reduce pesticide use with 10%, and to minimize the wrong decisions also by 10%. Another element was the price setting. So Process to Wine was the company supposed to market the product. It was estimated that the wine growers should pay around 250 euros per year for the delivered services. In this price, Process to Wine should calculate for the services that were provided by the other partners. This was not yet defined within the scope of this project. At the other side, the wine growers should have a return on investment by, for example, setting a higher price on a bottle of wine, or the investment could be partly compensated by all the cost savings that were made. Also, this was still open at the end of the project. Business modeling is accompanied by various issues concerning governance and ethics. Taking this price setting chain, the following questions or issues could be raised. So, will Process to Wine get access and control over all data of the wine grower? Or can the wine grower use the same data also for other purposes? Will the tool be made available to all wine growers? Or will an association such as Vinidia claim that it is only available for their members? And what is the effect on the market position of a company such as ST Microelectronics? Will they become very powerful in the end? And finally, researchers could have a bias and their particular view on sustainable wine production and their analysis. So many of these issues were discussed in various group settings guided by experts. And not all these issues were solved in the end, but the stakeholders greatly appreciated that they were now aware of them. And it should be noted that in this presentation, only a limited number of aspects of this use case could be highlighted and illustrated. In reality, the development was much more dynamic and complex. So big wine optimization was one of the 33 use case projects that were conducted all over Europe in the iOS 2020 project. Within that context, it was also possible to learn from each other, from the other use cases coming from different sectors and backgrounds. And this effect was enhanced by having a dedicated team from various disciplines that supported all the use cases. So if you want to learn more about this big wine optimization and other use cases that were done in iOS 2020, you can go to this use case catalog on www.ios2020.eu. I'm coming to a conclusion. So I have showed that the digital transformation of the agri-food sector is taking place and that there is a clear potential for sustainable food systems. And through the digital transformation, a lot of data is produced, which can be used for multiple purposes. You have learned that digital innovation is not only about technology, but that technical and organizational issues should be addressed at the same time. And therefore, digital innovation should take place in a real-life context by use case projects, following a multidisciplinary, collaborative, agile approach. And with that, I want to thank you for your attention.
Thank you very much, Dr. Wolfert. Now it's time for questions. If anyone wants to ask something to Dr. Wolfert, please use the chat. Yeah.
Oh, it's a very long question. Should I believe that societies, organizations, and ethics will prevent agricultural digitalization, in particular in countries with non-democratic governments as well as in non-developed countries, which will be the future of Agriculture 4.0 in real time to mitigate all the problems that agriculture is facing? Yeah, I think that's an interesting question. And so, as I indicated, we executed the use case project that I showed was part of a larger project. And as I said, we had dedicated teams that were working on these governance and ethical issues, for example. And then they were also able to put all the issues together from different perspectives, and also to discuss them with policymakers and also with business associations. So amongst others, this has resulted in this code of conduct for agricultural data sharing. That is a voluntary guideline that can now be used. And this is an example of how you also try to address from these type of projects, higher level issues. And then I can also imagine that you can also try to address these kind of issues, although, well, sometimes it's difficult to get to the right solution. That's for sure.
Okay, thank you. Any other question? No, so thank you again, Dr. Wolfert, for joining us and accepting to be a keynote speaker in our workshop. Thank you very much for your presentation.
It was my pleasure. Thank you.
Thank you very much. So as stated in the program, now we are going to take a little break. So we will join again in 30 minutes more or less at 11 a.m. Thank you very much and see you in a while.